Hello and welcome to our short introduction to Typhoon HIL real-time simulation platform. This simulation platform includes a software and hardware component. Throughout the course we will refer to the hardware part as a HIL device. In this module we will start with some basic information about the processor architecture, followed by some connectivity options. Lastly, you will be able to see some of the interfaces available for you to test your control algorithms. Let's start with the HIL device architecture. Typhoon HIL device models vary in processing power, but share a common multiprocessor architecture which contains a Typhoon FPGA solver, system CPUs, and user CPUs. The multi-core FPGA solver is optimized for time-exact simulation of electrical domain models. Its main HIL application is to simulate the electrical part of the plant. User CPUs represent one or more general-purpose processors that are under direct user control. It is used for simulating non-electrical domain parts of the plant model, mechanical, thermal, signal processing, among others. It can also be used for developing plant controller algorithms. This means that in addition to assisting the FPGA solver in simulating the full plant, the user CPU can be used for rapid control prototyping. System CPUs represent one or more processors that are indirectly controlled by the user. They are typically used to simulate low dynamics phenomena of certain electrical domain components or to handle communication protocol stacks. This was just a brief introduction into the processor architecture. We will revisit it in more detail throughout the course after we get a better understanding of the challenges of model-based design for real-time simulation. Right now, let's have a look at HIL device from the outside and learn about its connectivity options. The front side of the device contains an I/O pinout for analog and digital signals as well as an on-off button. The number of I/Os available depends on the device that you are using. The device that we are demonstrating today is from the HIL 6 series. HIL 604. This device contains 64 analog outputs and 32 analog inputs. It also has 64 digital inputs and 64 digital outputs available. Analog inputs and outputs have a resolution of 16 bits with a voltage range of ±10 volts. Digital inputs and outputs are standard 5V CMOS logic I/O, fully protected up to 24 volts. For more information on hardware connections, check out the link to the HIL 4 6th series hardware user guide. Now that we've finished with the front side of the HIL device, let's move to the back side. The ports contained here can reorganize in three groups: communication ports, high-speed serial link, and an AC power supply. The communication ports group contains a RS-232 port which is intended to be used for serial communication. Additionally, there are two CAN ports for CAN communication, a PPS and iRig-B port for time synchronization, with GPS and other telemetry devices, two Ethernet ports for different communication protocols, and one USB port for connecting the HIL device to a PC, the Typhoon HIL Control Center software. That communication is enabled via high-speed PCIe 5 GHz serial link. It is important that you set the device ID to be different for each device when using parallel devices. The HIL ID should also be set with a rotary switch, which can be found next to the high-speed serial link connectors. Now that we've covered the connectivity options, let's look into the interfaces. Typhoon offers a growing catalog of interface solutions that you can use to connect your controller's I/O stage and close the control loops with the simulated plant. Some of the more popular interfaces include the DSP-180 interface, Launchpad interfaces, the HIL Breakout Board, HIL DS interfaces, and HIL Connect. The DSP-180 interface for TI cards is the way to go for those who want to accelerate development of power electronics applications for Texas Instruments C2000 family of DSPs. Digital and analog connectors on the DSP interface are standard 96-pin and 41612 connectors that are directly pluggable into the analog and digital I/O connectors of the HIL device. When you use this interface, You can use 24 analog outputs from the HIL device to connect to the DSP controller. HIL analog outputs are scaled on board from ± 10 volts to DSP's ADCIN, from 0 to 3 volts. In addition, there are 40 digital signals, 24 inputs and 16 outputs, available between the HIL device and the DSP. Texas Instruments DSP cards can be connected to the DSP interface by plugging them in directly to the DIMM connector. The DSP interface card has the built-in circuitry required for the USB communication and power supply for the DSP. The next interface is the TI Launchpad, which contains the DSP card and all other supporting circuitry for communications and power supply, including DSP IOS available on the standard 100 mm headers. This means that the Typhoon Launchpad interface enables easy plug-and-play connection of the Launchpad board to Typhoon real-time simulators. The Launchpad interface supports 20 analog signals, 16 analog outputs and 4 analog inputs. Some of the TI Launchpad boards from C2000 and Hercules series supported by the Launchpad interface are shown here, including the F283790 controller, which is one of the most popular among TI users. The HIL breakout board is a passive interface. It consists of spring cage terminal blocks with HIL I/O lines routed for easy and quick wire connection. It gives you full interfacing flexibility if you have a custom controller board and require additional I/O connections. The HIL DS interface allows you to easily connect DSpace hardware RCP devices to Typhoon HIL simulator. There are two types of interfaces: HIL DS interface type A and HIL DS interface type B. The HIL DS interface type A provides a pin-to-pin compatible interface between all Typhoon HIL emulators. 4 series and 6 series and DSpace's microlab box, front panel variant. The HIL DS interface type B is a top panel variant interface which works with both DSpace's microlab box and DS1103 controllers as well. Last but certainly not least is the HIL Connect interface. HIL Connects enable realistic emulation of current voltage transducers and conditions controller I/O signals that are outside of HIL device range. It can emulate LEM sensors, current transformers, voltage sensors, relays, temperature sensors, and other low-power sensors. Also, it does input-output impedance matching. You can find out more detailed information about HIL Connect interfaces in the video below. Now that we've explained the different interfaces, what might a simple C-HIL setup look like? Let's look at one now. As you can see, we have a Launchpad interface and one Launch XL F283790 controller. The interface is connected with a HIL 604 device through DIN connectors. The USB cable you see is intended to be used for communication between the controller and your PC. So now you have an idea of what a simple HIL hardware setup looks like. In the next videos, you will get to know the Typhoon HIL software and learn to build models and get them running, so see you in the next video. Thank you for watching.